All right, there we go. Much better. All right. So yes. Angles. In fact, we can say corresponding angles. Okay, are congruent. All right, so since the corresponding angles in triangle 1 and in triangle 2 are congruent, what can we say about those two triangles? That they are what? They're going to be similar. By what similarity? Yeah, angle, 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 or really you just say angle, angle, similarity theorem. Okay, so then it says do the same thing that we did for triangles 1 and 2. Now do them with triangles 1 and 3. Okay, so now with 1 and 3. What's true about their angles? They're also equal, okay, and so we can say that triangles 1 and 3 are similar. So yes, corresponding angles are congruent. So triangle 1 and 3 are similar by angle, angle, similarity theorem. Okay? Okay, so there's that. Now, some more questions, right? How are the hypotenuses of triangle 2 and 3 related to triangle 1? So how does the hypotenuse of triangle 3 and the hypotenuse of triangle 2, how does that relate to triangle 1? Or specifically, what parts of triangle 1 match to the hypotenuses of 3 and 2? Yeah. The legs, exactly right. Okay. So the hypotenuses of triangles 2 and 3, the hypotenuses of triangle 2 and 3 are the legs of triangle 1. Okay. We talked about how 2 relates to 1, and we talked about how 3 relates to 1, but how about what's the relationship between triangles 2 and 3? What are they going to be? Similar as well, okay? Okay, if they're both similar to triangle 1, then they're also going to be similar to each other. Okay, it's the transitive property there. Okay, transitive prop. Okay, so with the scenario that we did, we took triangle 1, okay, and we drew a height from its hypotenuse. Okay, we drew a height from its hypotenuse, its altitude from the hypotenuse there, and that created these two smaller triangles. Okay, so when you draw the altitude to the hypotenuse of a right triangle, what kinds of figures are produced? Well, we get two triangles that are similar. Okay, two similar triangles. They're similar to the original and each other. Okay, and so that's the key thing here, right? That hypotenuse, that altitude that we drew there, created two similar triangles that are similar to the big triangle and similar to one another. Okay, so it kind of creates three similar triangles. The big triangle, and then similar to the two smaller triangles. And they're all three similar to one another. Okay? All right, so we'll skip this one right here and move on to the next page here. So how are we going to be using that today? Well, first, before we talk about how we're going to be using that idea today here, we're going to talk about something called a geometric mean. Okay, a geometric mean. Now, to talk about geometric means, it might be helpful to first review what an arithmetic mean is, right? So how do you normally find the mean of something? What do you do? The mean or the average of something, what do you do? Yeah?
You add the numbers up and you divide them by however many there are.
Right, so if we give you two numbers, their mean is you add the two numbers up and you divide by 2 in that case, right? And we actually end up, that's actually called the arithmetic mean, the arithmetic mean, okay? The reason why we call it an arithmetic mean is because it comes from the idea of an arithmetic sequence. You guys remember talking about arithmetic sequences back in Algebra 1? Or arithmetic sequences back in Algebra 1? No bells are ringing here? Yes, remember that? Okay. So, do you remember anything about what an arithmetic sequence is?
No.
Okay. So, for example, this is an arithmetic sequence. Okay. What's happening every time here for our pattern? We're adding 2, right? So, an arithmetic sequence is you add by the same amount each time. Okay. One way to find a missing number in the sequence, is to add the two numbers together before and after it. So add the 10 and the 14 together, 10 plus 14, 24, and then divide by 2, and that gives you 12. Okay? So you can find this by doing the arithmetic mean of 10 plus 14 divided by 2. Okay, which gives you then that 12. Okay, so for an arithmetic sequence, if you're missing a term, you can just find the arithmetic mean. Well, similarly, right, we had arithmetic sequences, we also had geometric sequences. Okay, already did you guys talk about geometric sequences too? Do you remember?
I don't really remember.
Okay, you're like, I don't want to answer yes or no because Mr. Roman's going to ask me what it is then. All right, so geometric sequence, okay, an arithmetic sequence, if we add the same number every time, what's geometric sequence going to be? Multiply the same number every time, right? Exactly right. That's the idea there. So, for example, it'd be like 2, 4, 8, 16, 32, etc., right? Okay, so this is multiply by the same amount. Okay, and it turns out then if we have a missing term, we can use something called the geometric mean to find that missing term. Okay? So what is the geometric mean? The geometric mean is merely this. Okay? It is the solution to the proportion a over x equals x over b. A over x equals x over b. Okay? A over x equals x over b. Okay? What are the a's and b's? The a's and b's are the two numbers whose geometric mean 1 to 5. So in this case, for letter A is 4, B is 25. Of course, you can flip those around, say B is 4 and A is 25, but that's the idea there. Okay, so if we set this up then, we get, well, you can see here, the 4 over the x equals x over 25. I'll kind of zoom in on some on that now. Okay. We can cross multiply 25 times 4 and x times x. So 25 times 4 is 100 equals, and then x times x, what does that give us? X what? X squared, right? X to the 2. We multiply x times an x. And so then what do we do now to finish solving for x? What should we do to both sides? How do you undo a square? Square root. Let's get x equals 10. Okay, and again, we're going to leave just the positive number here. Okay, a geometric mean is the positive solution there. Okay, so let's try 9 and 20. Okay, find that geometric mean. Whoops, so I'm off the screen there. There we go, 9 and 20, let's find that geometric mean. So that geometric mean will be 9 over x equals x over 20. Okay, we'll cross multiply here and solve. So 9 times 20 180, and then x times x, x squared. Okay. So again, this is the geometric mean we're finding here. And then how do we get the x by itself? What should we do to both sides? Square root. So we get x equals the square root of 180. Okay. And then 180, is that a perfect square? It is not. But we can break it up into, let's see here. Well, I know, for example, let's see, 180, I think we can divide that by, let me do this, make it easier. Okay, 180 divides by 36. That makes it nice. So it's 36 times square root of 5, and the square root of 36 is 6 square roots of 5 there. Okay, so there it is, simplified. Okay. Okay. You can see here that every time, if we want to find the geometric mean of something, we're going to have x squared, right? The x is going to multiply together, and we're going to have the two numbers multiply together. So if you wanted to, you can kind of skip the ratio part if you want and just say x squared equals and then a times b if you want. All right. So anyway, go ahead and try, pick 6 or 7, one of those two at the bottom there, and try that on your own. Find the geometric mean of one of those two. Okay, I'll give you like a minute. Go ahead and try and find the geometric mean of one of those two there. Okay. 30 more seconds here. 30 more seconds. Okay. So, should have gotten here, for number 6, you should have gotten 12. For 7, you should have gotten 2 times the square root of 15. 2 times the square root of 15. Or square root of 60 if you didn't simplify. Question on either of those. Before I lose my paper there. Question on 6 or 7. All good? Okay. I think I'm actually going to skip the next page and let's just go to page 667. Okay? Because I don't think we really need to worry about those theorems right there. I think we can figure these out without the theorems here. Okay? So, we're going to use here, I know it does say it's using geometric means and stuff like that, but again, I think we can get away with this without having to use geometric means theorem. Okay? So, what we got here is a situation to what we did earlier, right? A situation similar to what we did earlier, where we have a big right triangle, okay? And then from the hypotenuse of that big right triangle, we have an altitude drawn, and we have a lot of missing values, right? Y, X, and Z. And we are asked in letter A to come up with the value of X with all this information kind of missing. All right, but we can set up proportions because we know this smaller triangle is similar to this medium triangle, which is similar to this big triangle here, right? And so all those similarities result in us being able to set up some ratios and proportions because we have all those similar triangles. Okay? Now, let's consider x right here that we're trying to solve for. Okay? X is what part of the small triangle? What kind of part of that small triangle is it? Well, it's 2 is the leg here. X then looks like is also a leg, but it's like the longer leg. Right? X is like the longer leg of that right triangle. Okay? So you want to match like x to the 2 is what you're saying? Okay, I see what you're saying now. So x, it's a long leg, and Madison said let's match that to the 2, which is the short leg. So it's like x over 2 is what you're saying? I see what you're saying. Okay, yes, okay, you were jumping. Okay, yes. So let me. I see what you're saying. Yes, that's a better way to think about it. Yeah, I like that. So x, okay, is the short leg of the medium triangle, right? You see that right here. X is the shorter leg of that medium triangle, which then corresponds to the 2, the short leg for the smaller triangle. So we can make that similarity right there. X corresponds to the 2. Equals. Now we need to come up with we need to come up with another ratio between those two triangles. Okay. So let's see if we can do that here. Well, x is also the long leg. It's the long leg of the smaller triangle, which corresponds to what's the long leg in the medium triangle? 10. So we did short leg of medium over short leg of small, so x over 2. And we're going to do long leg 10 over short there x. And so we end up with that. X over 2 equals 10 over x. Okay, so I know it's a little bit confusing because we've got a lot of triangles going on here. So let me go through it one more time. Okay, one more time here to show you. The x here, we're considering that to match up to the 2. Because the x is the short leg of the medium triangle over the short leg of the small triangle. So x over 2. All right, that's where that comes from. In addition, 10 is the long leg of the medium triangle, and that matches to x, the long leg of the small triangle. So 10 over x. Okay. So now I can cross multiply. X squared equals 20. Okay. So then x equals the square root of 20. Right, which is equal to 2 square roots of 5 when you simplify it there. Okay, 2 times the square root of 5. That's the idea. All right. Now letter B also asks us to solve for y. So let's go ahead and solve for y there too. Okay. So y is, what can we match that to? Y is what part of what triangle? What can we say? Okay, y is the hypotenuse. Y is the hypotenuse of the medium triangle. Okay, so y, what's another hypotenuse we can match that up to? Okay, z is another hypotenuse, but then we're going to mix our variables together. Do we want to mix our variables here? Yeah, probably not. Okay, so what's another hypotenuse we can match it up to? 12, right? The hypotenuse of the big triangle. So we can say y over 12, and I'll do this one over here maybe. So we'll say y, which is the hypotenuse of the medium triangle. So this is medium over big. Okay? So we need another measure from the medium. Okay? What's another measure from the medium triangle? Right, we got 10. Okay, 10 from the medium triangle there, which is that leg. What's the long leg of the big triangle then? Y. Okay, so again, multiply, cross multiply. Y squared equals 120, square root both sides. You get y equals the square root of 120, which, let's see here. 2, 3, 5, yeah, okay. So, which we can simplify to be the square root of 4 times the square root of 30, which is 2 square roots of 30, and that doesn't simplify any further. Okay. Questions on that? All right, shall we try one more together? Or you guys want to try it on your own? One more together? One more on our own? Silence. Okay, we'll do one together since we're not confident enough to say let's do it on our own. All right. So let's take a look at number 10. We're just going to find x in this case. Okay. This one's a bit trickier just because of the triangle is not drawn so distinctly here, but I think we can get away with this. Okay. So here's x. We want to solve for that. Okay. X, we'll say, is the long leg of the smaller triangle right here. Okay, I think x looks a little bit longer than the 5 there, right? So we'll say x over, and then what's another long leg that we know from another triangle? 7. Yeah, x over 7. 7 is the long leg of the medium triangle right here. Okay, so we did small over medium, and so we need another small over medium ratio. So what's another measure from the small triangle that we didn't use? The 5, yeah, 5. And what does that correspond to in the medium triangle? The x, yeah, the other short leg there. Yep, exactly right. Oh, sorry, I'm off the screen. There we go. So we cross multiply. X squared equals 35, square root both sides. X equals the square root of 35. There's no way to simplify that square root of 35. There's no perfect squares in there, so we just can leave it like that. Okay, so that is our x. And again, we're not doing the plus or minus in this scenario because it wouldn't make sense in the context. We're throwing out that negative. Even though we're square rooting in an equation setting, we're going to throw out that negative. Okay. So, questions on any of that? All right, we'll stop there. That was nice and fun for a day back again. So, here is what I will have us do. I'm going to assign for homework here. So I'll just give you a short homework assignment so that way you guys can start on the review if you want to as well. I'll post that on the Google Classroom here. So I'll just give you a short homework assignment. We'll say page 671, numbers. I don't know, let's say 4, 10, and 11. Okay? That's all for your homework. Okay, and I'll say start work on review. Which I will post on the Google Classroom. Okay. And of course, if anyone has any questions on the TenMarks assignment too, okay, if anyone has questions on the TenMarks assignment, let me know. I can help you with that as well. That is due Wednesday evening.